Well, hey there, everybody. It's your boy, Mr. Perry, and here we are continuing the journey. We are at Unit 6, Lesson 1, and it's finally time to start talking about arrays. So let's go ahead and get into it. All right, so before we get into arrays, the first thing we want to talk about is why we need what's called data abstraction, because arrays are an example of data abstraction. And in order to exemplify that, we're going to look at a little code block here, right? So we've got three grades that are all initialized as integers. And what if we wanted to write a program to print out the maximum in this entire list? So what we would need to do is we would have to just basically set the max to be 0 initially, and then check all of the grades. If grade 1 is greater than the max, then the max will be set to grade 1, so it would be set to 97. But then we would need to check the rest as well. So we would need to say, well, what about, if grade 2, is that greater than 97? Of course, it's not, so it wouldn't be. And you would basically have to go through and check each individual grade to see if it's greater than the current max. And if it is, reset it, and then finally print it out, right? So the code to the left that you see right here is pretty simple. But the question is, what happens if you had 10 grades or 100 grades or 1,000 grades? We would have all of these different variables, and we would have all of these different if statements, and it would get really, really messy. So using a data type called an array will allow us to greatly simplify our code to just a few single lines, so no matter how many grades that there are. And creating an array as opposed to using separate variables is known as data abstraction. It's basically taking a bunch of data and abstracting it, simplifying it, and presenting it in a simplified form. So that's really what arrays are all about, and where we're going to be going next with the class. So what is an array? Arrays are a data structure. Rather than a data type, we say they are a data structure because they structure different data. And what it is it's used to store multiple values of the same data type. They provide a block of memory that stores a collection of items of the same type under one name. So down here we're just getting a glimpse of what arrays look like in Java. This says int array scores equals new int array with a length of 5. And then down here, string array Avengers, and we're setting it equal to Captain America, Black Widow, Thor, and so on and so forth. So this is what arrays look like. And again, they are a way of structuring data and providing a block of memory to store all of the values that we're going to be putting in that array. Now, arrays contain what are called elements. So the elements in this one would be my quiz scores. We have an array of integers called quiz scores with all of these values. So down here, the elements are 89, 76, 92, 95, 84. Now, those elements are located at various index values. And of course, the index starts at 0 and works its way all the way up to the length minus 1. So very similar to what we saw with strings. Speaking of strings, arrays are also what we call reference data types, just like strings and objects of a class file. So with this example that you see down here, the name quiz scores is a reference to a memory location, which you see right here. Again, quiz scores points to an area in memory where all of these values are being stored. So just keep that in mind that arrays are reference data types. And just like strings, the index value for arrays begins at 0, and then the final element is always located at length minus 1. So again, a lot of similarities with strings. And then another thing that you can do is you can refer to the index of specific elements in an array using the format, name of the array, and then the index value in square brackets. So for instance, if I had an array of integers called grades, and it's got all of this in here, I could actually extract some of these values and store them as separate variables if I wanted to. So I could say int g1 equals grades at 0. So that would mean, okay, grades is the name of my array, and 0 is the index value right there. So that would take 89 and store it in the variable G1. And I could do the same thing for G2. G2 equals grades at index 1, which means 76 would go right here. And then int G5 equals grades, and then I could also do this in square brackets. I could say grades.length minus 1, and that's always going to refer to the very last element in that array. So there's this is how you can access each individual element. And then let's look at how we create an array. So to create an array, it's actually very similar to the basic syntax for creating objects. If you want to create an object of a class, you have the class name, the object name, and then you put equals new, and then class name with parentheses and any arguments. So string name equals new string Perry. This calls the string class constructor and assigns Perry to the variable name. Now down here, the basic syntax for arrays is very, very similar. You have the array data type followed by square brackets, and then the name of the array, and then equals new. And then you just repeat this again over here, the data type and square brackets. But then over here, this is also where you put the number, and this is the length of the array. So if I wanted to create an array of strings, I would say string array, and then call it names, and set that equal to new string. And then again, I'm setting the length of this to be 10. I could put any number here that I want to. I'm just kind of arbitrarily choosing the number 10 here. All right, so there are basically two ways to declare and initialize an array. The first option is to declare the array using the new keyword and then initializing the elements one at a time. So if I do it this way, which is kind of the longer way of doing it, I would say if I wanted to have an array of scores, I would say int array scores equals new, int, and then I would put 5 in here. And then I would say, then I'd have, this would create an array of just like all zeros. So if I want to actually assign values to them, I would have to say scores at 0 is equal to 89, and then scores at 1 is equal to 76, and then scores at 2 is equal to 92. So this is basically going through and saying at each one of these index values, let's go ahead and add these values. One thing that's important to note is that you must put a number in the second set of square brackets to identify the length. If you leave this empty, you will get it'll throw an error. But basically what we're doing here is we're creating an empty array or an array of all zeros, and then we're going through and reassigning each one of those values, each one of those elements a different value. And so, yeah, there you go. So the first line creates an array of integers called scores and sets the length to be 5. And then again, you can put the actual values that you want to assign. You can do it this way. However, there's an easier way of doing it. Oops, I'm sorry. Before we get to that, again, when you create an array, before you assign the values to it, Java automatically fills the array with the default values for that data type when the array is declared. So when I say int array scores equals new int 5, it creates this array down here. And then what I need to do is I need to start going through line by line and putting, okay, this is now 89, and then scores at index 1 is 76, scores at index 2 is 92, and so on and so forth. So by the time we get to the end of this little algorithm, we've got all of our scores set in there. Arrays of primitive data types are always initially set to their default values. So if I did an array of doubles and called it temperatures and gave it a length of 7, then that array is going to have 0.07 times. And if I did an array of Boolean values and called it has food and set that equal to, a length of 10, again, all of those Booleans are going to be set to false, and that will have a length of 10. If I create an array of reference data types, they are always set to null. So if I did string array, called it names, set it equal to a new string array with a length of 3, then I would have an array of 3, and again, all of the strings would be null. And then the same thing down here, if I wanted to create an array of albums, I would say, album array and then call it my albums and set it equal to new array of albums with a length of 500. And again, that would just be 500, little boxes, all with the value of null. Arrays only contain the actual values if they are initialized one at a time after the array has been declared. So again, if you declare an array like this, you have to go through and initialize each individual element to be what you want it to be. So this little algorithm that you see right here, I'm only doing the first three elements. So that means the other 4 would be set to 0.0. So that's just important to know that this is kind of how arrays work. Now, I mentioned there's an easier way of creating an array, and that's what you see right here. This is what's called an initializer list. So the second way to create an array is to use an initializer list. And again, it's much easier. So basically all you do is you put in the data type with your square brackets, then the name of the array, set it equal to, and now what we do is we open curly braces, and we just fill in the blanks with whatever we want, separated by commas. So int array scores is equal to, and you can see I'm just putting them in this time. So this creates my array for me. I don't have to worry about, okay, at first they all have zeros, and now I have to do, each score one at a time. This is just a lot easier to do it this way. So there you go. Initializer lists automatically set the length of the array based on the number of elements between the square brackets. So if I did my Avengers string array, I would say string array Avengers equals, and then in curly braces, the name of each individual Avenger followed by commas. So that would go ahead and set the length of this one to be 6. And there you go. All right, what else do we need to know? So let's talk about the dot length aspect of arrays. So arrays have a public instance variable called length that you can access. So we're not used to seeing this. Normally instance variables are private. However, arrays are a special class with kind of some unique idiosyncrasies, if you will. And they do have an instance variable called length that is public. And so if I create an array of scores, what I can then do is I can say int num scores, or number of scores, equals, and then I can just do scores.length. So I just need the name of the array, and then the dot operator, and then the word length, and your semicolon. Now this is slightly different from what we've seen in the past. We're used to using the length method with the string class. Strings have a public method called length with, again, the parentheses, because it's a method that does the same thing. But again, when you're working with strings, you need to remember the parentheses, because again, you're calling a method. So string city equals White Lake. I could say int num equals city.length, and again, with the parentheses, that will return the number of characters in this string, and it'll store it as my variable num. But again, this is different to how we do things with arrays. With arrays, it's very similar, but we just need to remember that we don't use the parentheses when we're dealing with length, because again, it's an instance variable that is public rather than a method that you are calling. All right. And then another thing that's very common with arrays are what are called parallel arrays. So oftentimes programmers use multiple arrays to store related information. And again, this is called using parallel arrays. So if I had an array of car numbers, and then I needed to, so let's say we were having a race, right? And you had car number 101, 102 number, and so on and so forth. I could create an array of car nums, and that's an array of integers. But then I could also create an array of doubles to store their times that they, maybe completed a lap or whatever, they were doing. And then down here, what I could do is I could print, car number, and then add car nums at 0, which would be 101. And then concatenate had a time of, and then times at 0, which is 5.3, and then add your period. And then, again, could do the same thing, car number, and then car nums at 1, which would be 102, had a time of, and then again times that one, which is 4.9. So you can see how these arrays kind of work together to store related information, and you can then use your print statements and access the different the different index values to just make sure that your information is coinciding the way you want it to coincide. And again, if you like strings, if you try to access an index that's outside of length -1, you're going to get an error. So if I tried to do carnums at 5, and again, the length of this is 5, which means I can't access an index greater than 4, because that's length -1. So if I try doing carnums at 5 and then times at 5, I'm going to get an array index out of bounds exception. So this is the error message that you get when you try to go outside the bounds of an array. And then arrays are also immutable. So like string objects, arrays are immutable, meaning that meaning you cannot change their length once it is initialized. So if you had an array of scores like this, and then let's say you had another array of more scores, and let's say you wanted to actually combine these into a single array, you can't just add more to it. Again, once arrays are initialized, you can't change their length. They are immutable. So we're going to learn how to use loops to create new arrays to solve problems like this one later in the unit. But that's just good information to know moving forward. All right, guys, well, with that, we're to our lesson review. So let's go ahead and just run through it. Arrays represent collections of related data, all of the same data type. The size of an array is established at the time of creation and cannot be changed. They are immutable. Arrays can store either primitive data types or object reference data. When an array is first created using the keyword new, all of its elements are initialized with a specific value based on the type of elements. So again, ints are initialized to 0, doubles are 0.0, booleans are set to false, and then reference data types are always null. And there you go. Initializer lists also can be used to create and initialize arrays. In fact, that's usually how I do it when I'm working with arrays, just because, again, it's much easier. Square brackets are used to access and modify an element in an array using an index. And the indexed array variable can be used anywhere that a regular variable can also be used. And then finally, the valid index values for an array are 0 through the length of the array -1 inclusive. And again, using an index value outside of that range is going to give you an array index out of bounds exception. All right, guys, that is it. Don't forget to leave a question or comment, and I will see you, as always, in class.